horizontal lines, vertical lines, parallel lines, and perpendicular lines. Horizontal lines. This is an example of a horizontal line, as you can see. Horizontal lines are described by the equation of y equals to a number. This is how we sketch a horizontal lines. So if you see y equals to -3, that would refer to a horizontal line where the y value is -3. So go to -3 and draw a horizontal line. Now you might wonder why this is the case. Well, remember that lines consist of an infinite order pairs. So if you're given this equation, then we need to find points that satisfy this equation. So points that satisfy this equation must have y coordinates of -3. So for example, if you chose 1, -3, does it satisfy this equation? And the answer is yes, because this equation has nothing to do with x. So this 1 has nothing to do with this equation. All you have to do is replace -3 into here, and you have a true statement. Similar, if you chose, for example, 4, -3, that is also a solution as long as the -3 is the y value. As you can see, these points fall on the line. So then, for example, 1, -3 is right here. 1, 2, 3. This is 4, -3. See? Vertical lines. Vertical lines are described by x equals to a number. This is the equation of a vertical line. Example, x equals to 2. X equals to 2. To graph x equals to 2, we go to the value of 2 on the x-axis. Maybe put a dot there, and then construct a vertical line. The same argument can be used to show why this is a vertical line. Alright, so remember, lines are made up of an infinite number of points. So what are points that satisfy this equation? Well, any point that satisfies this equation must have x-coordinate of 2. And the y-coordinate, let's say if we chose 1 again, does it satisfy this equation? And the answer is yes, because this equation doesn't have a y value. Therefore, this number has nothing to do with the equation. So when we try to check our answer, we only plug this in. So when you plug 2 in here, it's true. Okay, let's come up with another one. 2, -2. Remember, the x-coordinate have to be 2. There's no option there. We don't have any options of getting a different x-coordinate because it won't satisfy this. All right. Again, this number has nothing to do with it. If you take x equals to 2 and plug it in here, it makes the equation true. So therefore, these 2 points fall on the line. If we were to plot these 2 points, 2, 1 is here, and 2, -2 is right there. And as you can see, it falls on a vertical line. That's why these are vertical and horizontal lines. Parallel lines and perpendicular lines. Here's what we know about parallel lines and perpendicular lines. 2 lines are parallel if they have the same slope. And 2 lines are perpendicular if the product of their slope is -1. So first of all, let's take a look at 2 parallel lines. So here is an example of 2 parallel lines. As long as they have the same slope, they're parallel. Okay, so that's one of them. This is line 1. Let's call this line 1. And then draw a second line that has the same slope. Okay, here is line 2. These 2 lines are parallel because they have the same slope. The slope of the first line is going to be 2 over 2, so that's 1. The slope is 1. The slope of the second line is 2 over 2, which is also 1. So they have the same slope. They're parallel. Okay. Perpendicular lines. let's take a look at two lines that are perpendicular. So let's consider this line here. Let's call this line number 3 and then line number 4. Let's make this line number 4. So these two lines are perpendicular, and they're perpendicular. Notice that when they're perpendicular, their slope is not the same, obviously, but there's one special characteristics. If you look at the slope of the first line and the slope of the second line, if you multiply them together, the slope will be -1. So the slope of the first line, we made it the slope of the first line. Here's the line 3. The slope is 1. Okay. The slope of the second line is, if we start from here and we go up and we go to the left, that slope is -1. So for line number 3, the slope is 1. For line number 4, the slope is -1. But if you multiply them together, you get 1. So the product of the two slope is -1. And that's one way to check to see whether or not two lines are parallel. Okay. Well, another way to check and see whether or not two lines are parallel is that their slopes are negative reciprocal of each other. So for example, if line 3 and line 4, say given that line 3 and line 4 are perpendicular, and the slope, this is the slope of line 3, okay? The slope of line 3 is 2/3, okay? Then the slope of line number 4 must be negative reciprocal of line number 3. So the slope of line number 4 must be negative reciprocal of line number 3. So it has to be -3/2. Graph and, if possible, determine the slope. If the slope is undefined, state this. Let's graph A first. So this is a special function, x equals to 3. We know that that refers to a vertical line from the previous page. So we first plot 3, x equals to 3, put a dot, and then draw a vertical line. The slope for a vertical line is undefined. So for part A, slope is undefined. Okay. Part B, to graph this function right here, we will go ahead and first note that this equation is missing the letter y, which means that it's going to also be a vertical line. Any equation that's missing a letter y is going to be a vertical line. So we begin by adding 10 to both sides, and that leaves us with 2x equals to 10 because we added 10 to both sides. And then we're going to isolate x by dividing both sides by 2. So x comes out to be 5. That's a vertical line. X equals to 5 is our vertical line. So go to 5, okay, and draw a vertical line on 5. Six minus 3y equals to 0. This last equation is missing the letter x, which means that it's going to be a horizontal line. So we begin by solving for y. So we will solve for y. first thing we do is we need to subtract 6 to both sides. So if we subtract 6 to both sides, this is what we have left on the left side, and this is what we're going to have on the right side. Divide both sides by -3. That brings us to 2. Y equals to 2 is what you're looking for. First, plot 2, and then draw a horizontal line through that point, and that's equation C. Okay? Slope for B, slope is undefined. Don't ever say no slope. Say undefined. For C, C is a horizontal line. It's a flat surface, so therefore it has a slope of 0. Without graphing, tell whether the graphs of each pair of equations are parallel, perpendicular, or neither. First of all, parallel means that the two lines will have the same slope. Perpendicular means that the two slopes will be negative reciprocal of each other, or their product is -1. If none of those two cases hold, then we say neither. So for part A, for the first question, part A, the first equation is 2x minus y equals to 6. We need to find the slope of this equation. To do so, we rewrite the equation in slope-intercept form. To do that, we subtract 2x to both sides. So we ended up with something like this when we subtract 2x to both sides. Divide both sides by -1, and that brings us to this. So therefore, we know that the slope is 2. Let's take a look at the second equation, which is x plus 2y equals to 5. So x plus 2y equals to -5. Subtract x to both sides. Divide both sides by 2. We get that. So the slope is -1/2. So here's the slope of the first equation. Here's the slope of the second equation. They're not parallel because the two are not the same. When we multiply them together, we do get -1, which means that they're perpendicular. So we say that this one is perpendicular. They're perpendicular lines. Okay, why? If the product of the two slopes is -1, then the two lines are perpendicular. B. The first equation is x plus 2y equals to 5. We solve for y, subtract x to both sides, divide both sides by 2. We end up with the slope to be -1/2. We do the same thing to the second equation. We subtract x to both sides. We divide both sides by 2. Slope is also -1/2. Because the slope are the same, we know that the lines are parallel. So they are parallel. Part C. 4x minus 3y equals 11. Subtract 4x to both sides. Divide both sides by -3. We have a slope of 4/3 for the first equation. The second equation, subtract 6x to both sides, divide both sides by -1. The slope is 6. Notice the slope they're not the same, so they're not parallel. And also, if we take the product, the product is not -1, so they're not perpendicular, so they're neither. So we say neither for that case. All right, find the x-intercept and the y-intercept, then graph the equation using the intercepts. In other words, the intercept is just another way that you can use to graph a line. So to find the intercept, it's actually pretty easy. Okay, I'll show you the easy way and I'll explain the idea behind it. To find the x-intercept, you are going to cover up the letter y like that. So let's make a chart here. Let's find the x-intercept. Okay, to find the x-intercept, you're gonna cover up the letter y, or cover up anything that is next to the letter y. If you cover that up, then you have 2x equals to 8. So 2 times what give you 8? Well, 2 times 4 give you 8, right? In other words, you want to replace x with 4. So 4, 0 is your x-intercept. Now, you might wonder why 4, 0? Well, when we cover up the y, that's the same as letting y equals to 0. You see? So if you cover that up, you have 2x equals 8. What should x be? X should be 4. That's how you find the x-intercept. So to find the x-intercept, you cover up the y. So this is what we mean by covering up the y, right? And if you do that, if you plug that in, you have 2x equals to 8 left. And if you divide that by 2, then x equals to 4. So the x-intercept is 4, 0. See that? So you go to here and you plot 4, 0. That's going to be the x-intercept. Y-intercept, same thing. To find the y-intercept, you cover up the x. So imagine you cover up the x. What do you have left? You have 4y equals to 8. So what does y have to be? 2. Good. So when we cover up the x, we're saying let x equals to 0. We have 4y equals to 8. That's left. Divide both sides by 4. Y equals to 2. 0, 2 is your y-intercept. 0, 2. This is called graphing using the x and the y-intercept. We have 2 points. Take these 2 points and connect them with a line, and you are done. You have graphed an equation using the x and the y-intercept format. Part B. Negative 3x plus 5y equals to 6. X-intercept. Cover up the y. This is what we have left when we cover up the y. X comes out to be negative 2. So negative 2, 0. Okay. Y-intercept. Cover up the x. If we cover up the x, then we have 5y equals to 6. And divide both sides by 5, you have 6 over 5. So 0, 6 over 5 is the second point. Negative 2, 0. 0, 6 over 5, that's another point. This is line A, so let's label that carefully. Now that's line, this is line B. And then let's do the last one, which is C. So part C. Notice part C is 2x plus 6y plus 3. 2x plus 6y plus 3 equals to 3. So we're going to go ahead and subtract 3 first. We want to, well, the reason why we subtract 3 first is because we want to simplify the numbers a little bit. So subtract 3 first, and that should give you that. So find the x-intercept. Let y equals 0. Cover up the y. You have 2x. You have 2x equals 0. So x, 2x equals to 0. So x equals to 0. Okay. Y-intercept. Y-intercept, cover up the x. You have 6y equals to 0. So y equals to 0. So this is one of the problems where graphing using the x and the y-intercept will not work. This is only true when the x and the y-intercept happens to be at the origin, which this problem is one of those problems. So for cases like this, you need to find another point that also satisfies the equation. To do that, it's actually very simple. Randomly pick an x value. So I am going to choose x equals to 1. Okay? So if you choose x equals to 1, take that and plug it in here, and then solve for y. So when I plug that in here, I get 6y equals to -2, because I'm going to have to subtract 2 to both sides. Therefore, y equals to -1/3. So it's a pretty small number. So 1 and -1/3. So 1 and -1/3, which leaves us right there. So this line right here would be our third line. Okay. Where the x and the y-intercept are the same.